with polynomials, and there's some terminology that I have a feeling is review, and so if this is all review, most of this period may be incredibly boring, and again, I apologize, but I've got to make sure everybody has it. All right, so what is a polynomial? Well, there's a technical definition. What I'm going to do is just give examples of things that are polynomials. I'll also show you things that are not polynomials. Right? So things that are polynomials look like this. 4x to the 5th plus 2x minus 1. 5x to the 4th plus 2x squared plus 3x plus 4, right? These are examples of things that are polynomials. Things that are not polynomials look like 1 over x plus 1 and the square root of x minus 2 or something like that. Basically, what you have to, polynomials have, you're adding terms that have x's, and the exponents have to be integers. So actually, not just integers, they have to be natural numbers. So just think positive integers. As far as these things, even though you have x's, if they're ever part of a fraction, it's not a polynomial. If they're part of a square root, it's not a polynomial. As far as classifying polynomials, we classify them in two methods. We classify them by the degree and the number of terms. And again, you probably already know this. Well, the degree is simply the highest exponent you have. Okay? So, like the degree of this polynomial is 2, because the highest exponent I have is 2. The degree of this polynomial is 5, because the highest exponent I have is 5. And the degree of this polynomial is 4, highest exponent is 4. Right? I will be making references to, when we start talking about polynomials, I'll say something like, here's a polynomial of degree 3 or degree 5 or whatever. And I just need to make sure you understand when I say that, it just means that that's the term with the highest exponent. Right? As far as number of terms, well, they've got a few words to describe things. If you've got one term, it's called a monomial, where mono is 1. If you've got, oh shoot, I should have had an example of 2 terms. If I have 2 terms, I'll sort of stick it in here. Let's say I have 2 plus 3x. This is called a binomial. And if you got 3 terms, well, we'll call it a trinomial. And after that, we're not going to come up with words for 4, 5, 6 and greater, so they just get tired and they say, well, it's called a polynomial. And technically, all of these things are polynomials. Because basically, poly means more, it means many, so this is a polynomial, this is a polynomial, this is a polynomial, and believe it or not, that's a polynomial, just a really, really basic one. All right, so I just need to make sure we talked about, when I talk about the degree, and then we use these words, but I think we've been using these words for a while, so you already know those. The last thing I need to talk about as far as just terminology with a polynomial is something called standard form. And standard form is that the exponents they decrease in order. Like, notice I have an x to the 4th, an x squared, an x, and then no x at all. See how it goes in order? That means it's in standard form. This is in standard form. It doesn't have to have all the exponents, but it's in standard form. This one that I had to squeeze in here, because I didn't plan well enough, is not in standard form because it doesn't decrease. Like, for this to be in standard form, I'd have to switch the order and say this is 3x plus 2. So, honestly, it's not that big of a deal. But our life is a little easier when you write your answer in standard form, because there's some patterns that are easy to identify when it's in standard form as opposed to when it's not in standard form. All right, that's a polynomial, right? That's sort of our polynomial vocabulary. The next thing we need to do are things with polynomials. And what do you do with polynomials? Well, we do some arithmetic. The first little bit of arithmetic is, what if I gave you 3x to the 4th plus 2x minus 4 plus 3x squared minus 5x plus 1. If I ask you to add, here's a polynomial, here's a polynomial. If I ask you to add them, you combine like terms. Like terms are things that have the same exponents. So for this one, I don't have any x to the fourth term, so when I combine these, it's just going to give me 3x to the fourth. As far as it, then I have an x. I only have one x squared term, so I'll put the plus 3x squared. As far as the x term, I have a 2x minus 5x. That's going to give me negative 3x. And then my constant term is negative 4 and a 1, which gives me a minus 3. And so I have added my two polynomials together. Y'all have done this a ton of times, right? This is not new information. All right. Next, of course, if I have to add, the slightly more interesting problem is, well, what if I wanted you to subtract them? And whenever you subtract, you just have to make sure you distribute the minus sign through the second part. So there's a minus 3x squared plus 5x minus 1. And so now when I combine like terms, I end up with 3x to the fourth. I have a minus 3x squared. 2x plus 5x gives me a plus 7x. And negative 4 minus 1 gives you a negative 5. So this is all review, right? Perfect, all right? I'm not going to spend a whole lot of time adding and subtracting polynomials because we've already done it, but I still need to review just a little bit. So next up, so I've talked about adding, subtracting. Next, we have to talk about multiplying. And that's where things get a little more interesting. First version of multiplying, let's say I give you 3x squared times 2x cubed minus 5x plus 4. Anytime you have a term outside, you basically just distribute. And so when I distribute, that means this term gets multiplied times everything over here. And this kind of relates to stuff that we talked about yesterday. So when I multiply these two together, this is going to give me 6x to the fifth. This is going to give me minus 15x cubed. And that's going to give me plus 12x squared. Multiply the numbers and make sure we handled the exponents appropriately when we did that part.
You need to put a 1 in front of the 5 for a negative 15 cubed.
15, yes, I probably did. You put it 15. I said 15, didn't I?
Yeah.
Okay, yeah, I'm pretty good about saying the right thing and then writing something. All right, so there we go for that part. Next, so multiplying by a monomial is not really a big deal. It's a little more interesting when, if I gave you, let's say I give you 2x minus 1 times, let's do 3x squared plus 5x minus 2. Let's talk about multiplying this part. I think this is the first time where I'm going to make sure that we handle this properly. All right, so how do you multiply this times this? Well, you kind of do the same thing. You just have to remember that this gets distributed to everything, and this gets distributed to everything. So how I do this is, well, this times this is going to give me 6x cubed. This times this is going to give me a plus 10x squared. And this times this gives you a minus 4x. Now, this guy gets multiplied. And so now when I multiply this times this, that's going to give me a negative 3x squared. This times this gives me a minus 5x. This times this is going to give me a plus 2. And now combine like terms, and that's going to give me 6x cubed plus 7x squared minus 9x plus 2, and there's your answer. Y'all done these before? Okay. All right, good. Your turn. And so I want you to do, let's see, let's give you 3x minus 2 times 2x squared minus 3x plus 4. Now when I add, that's going to give me 6x cubed minus 13x squared plus 18x minus 8. Curious. When you multiplied these out, how many of you multiplied it out and got a, didn't write it on top of each other, just do one big long line? Okay, there's nothing wrong with that. All right, absolutely nothing wrong with that. All right. The reason I show you this is if you write it this way, I think it makes it easier to combine like terms. So what the kind of the issue is when you write it on one big long, like when you just write one right after the other, sometimes it's harder to keep track of things because your like terms may be further apart. But if you put them here, they line up pretty well. So you don't have to do it this way. I'm just sort of showing, right? So here's an interesting problem. What if I give you x minus 3 times x squared plus 3x plus 9. Multiply those. One. All right, so this times this gives me x cubed. This times this gives me a plus 3x. This times this is going to give me a 3x squared plus, what's that, 9. So now this times this gives me a minus 3x squared. This times this gives me a minus 9x. This gives me a minus 27. Well, that's kind of neat. You get terms that cancel out, right? That is going to give me x cubed minus 27. And to be honest, the other examples I gave were completely random. I just put stuff up there. This obviously was not random, right? There was something that happened so that stuff canceled out. We actually had talked about this a couple of weeks ago. That part's not important now. It will be important probably in a couple of weeks. But I just want to give an example. Okay, here's where we're multiplying and something interesting happens. Now, the final, well, not the final example today, but sort of the last of the ugly stuff. I just want to see how you handle it. What if I gave you 2x squared minus 3x plus 1 times 3x squared plus 2x minus 4? Okay, multiply that out. So how do you handle this? Same way you handled the other ones. This term gets multiplied times everything. So this times this is going to give me a 6x to the 4th. This times this gives me a plus 4x cubed. This times this gives me a minus 8x squared. Then I go to this term. This times this is going to give me a negative 9x cubed. This times this gives me a minus 6x squared. This times this is going to give me a plus 12x. Then I go to the last one. This times this is going to give me 3x squared. This times this gives me a plus 2x. And this times this gives me a negative 4. Now, actually writing them on top of each other is a little more compact, and I think it makes it easier to see what needs to be combined. Because if you'd written all these out, you'd have to like sort of pick out, okay, where are my x4s, cubes, and you know, all the little parts. But, well, I've only got one x to the 4th term, so that's going to give me a 6x to the 4th. When I combine this, it's going to give me a minus 5x cubed. Minus 14 plus 3 is negative 11x squared. And I get plus 14x and a negative 4. And that's as ugly as it gets today. Okay. All right, are we kind of okay with this idea of multiplying polynomials? I do, probably should pause this because I don't. So the next, there's two types of problems I've got to talk about. And they're significantly faster than this. A whole lot faster than this. The first one is, if I give you like x plus 3 times x minus 3, is that an easy one to multiply? We can easily do that in our head, right? I mean, you look at this and you say, all right, you look at this and say that's a difference of squares? I mean, so you look at it and you say that's a difference of squares, so I know my answer is x squared minus 9, right? And you could go through the process of multiplying it out, and you realize your middle terms cancel. Okay, that's a difference of squares, right? And what the sort of the clue that it's the difference of squares is it's almost the same, except one's a plus and one's a minus. All right? Well, how do you handle it if it looks a little uglier? Let's say it was like x to the 4th minus 3y times x to the fourth plus 3y. Do you still see this is a difference of squares? Right? Anytime you have two binomials, they're multiplied together and they're the same except one's a plus and one's a minus, the middle terms are going to cancel out. You're going to create a difference of squares. And so how you get your answer, right, is I'm just worried about my first term and my last term. My first term came from x times x. My last term came from the 3 times negative 3. So in this case, my first term is this times this, which is going to give me x to the 8. My last term is going to give me minus 9y squared. So now I've multiplied it out. All right? Okay. So just to make sure that sinks in, what if I gave you, let's do 4x cubed plus 5y squared times 4x cubed minus 5y squared. You don't have to write the problem, but I do want you to write down the answer. And so hopefully this turned out to be pretty easy because we recognize it's a difference of squares, right? We know we're not going to get a middle term, so we worry about what's my first term. And that's going to give me 16x to the 6th, right? Because this times this gives me 16x to the 6th. My last term is going to be 25y to the 4th, and it's a difference of squares, so there's a minus. So is this an easy problem? Way easier than that other thing, right? Yes?
Is there always a minus for the difference of squares?
Well, okay, let's analyze what you just said.
No.
You said it's always a minus because it's a what?
Difference of squares.
What does difference mean?
Oh. There we go.
Math people are not creative when they name things, okay? Ever. There is always a reason, right? If you're just memorizing random stuff and you like, and even the wording is not creative, and that's by design. All right. So are we okay with the difference of squares, even if they aren't, I mean, that's about as ugly as it gets for difference of squares. All right, now this last topic isn't stressed in your book very much, and I don't technically need to stress it, but it makes our life so much easier in the future, right? And it has to do with squaring stuff. So, like if I give you x plus 4 squared, right? I want to talk about how we answer this question. And so, could you do this problem and say, well, x plus 4 squared, that's the exact same thing as x plus 4 times x plus 4, and then multiply it out? Of course you could, right? You can say, okay, well, that's going to give me x squared. Let's see, 4x plus 4x gives me 8x, gives me plus 16. So if you approach x plus 4 squared, and you wrote it like this, and came up with this, you could get the right answer. There's nothing wrong with that. It does get the right answer. Unfortunately, that's not going to help us when things get more complicated. All right? Here's what happens when you square something. Whenever you square a binomial, you're going to get 3 terms. Always. Right? When you square a binomial, you're going to get 3 terms. So let's talk about how we get those 3 terms. Your first term is always this thing squared. Your last term is always this thing squared. All right? The middle term. Here's how you get the middle term. You multiply these 2 things together and double it. So to multiply these 2 things together, I get 4x times 2. That gives me a plus 8x. Oh, also that last term is always positive. Okay? Let me go over that again. Anytime you square something, we're going to get 3 terms. Your first term is take this thing and square it. Your last term, take this thing and square it. It's always positive. And you get your middle term, you multiply these together, double it, put it here. All right? So your turn. What if I gave you 3x minus 5 squared? We're going to get 3 terms. What's the first term? 9x squared. What's the last term? 25, right? What's our middle term going to be? Positive or negative? Negative. Multiply these together, right? 3x times negative 5 gives me negative 15x. double it, that gives me my minus 30x, and we've done that, right? All right. What about this one? What if I gave you make that legible. Use the blue, the blue actually shows up better. What if I gave you 4x cubed minus 2y squared squared? So, when I square the first term, what do I get? 16x to the what? 16x to the 6th. Oops. See, what's going on in your head is 4x cubed squared, right? You square this, you get the 16, exponent raised to an exponent, you multiply. All right? So our first term is 16x to the 6th. What's our last term? 4y to the 4th. Okay? And that last term is always positive. Now to get our middle term, I multiply these together and then double it. So when I multiply them together, everybody see I get a negative 8x cubed y squared? And when I double it, what do I get? Negative 16 x cubed y squared. I mean, technically, you could just write it down twice and multiply it out. But what I really want is everybody to be able to go from here to here. Because this is important. All right, so I'll go ahead and we're done.